Ladies and gentlemen, it is 4 p.m. on Tuesday, the 2nd of February 2021. That means it is time for a brand new epic product launch. Live for Mission Control in Northwijk by the sea, we have selected epic members who each have an important development to announce to the rest of the world. Today, those companies are Miraex, Luceda, Teraxion, DEMCON, and Optoprim. Let's open up the Zoom room and get started. Welcome everyone to another news show of Epic, the Epic product release, that event in which the Epic members share new breakthroughs on the photonics technology. My name is Jose Pozo and I have the honor of chairing today's meeting. I would like to remind everyone that I work for Epic, the European Photonic Industry Consortium, that association that has now 670 members. We keep growing, but we keep understanding each company individually. And I would like to remind you, for those of you who have business in mid-infrared technologies, tomorrow we have a super cool meeting connecting mid-infrared photonics, from interactive photonics to the cameras to the QCLs, finding opportunities with end users. But today we talk about new product releases. We have an amazing agenda with a quantum sensing product from Miraex, with a new module in programming and designing photonic integrated circuits from Luceda Photonics, with a new module for Acousto-optic manipulation of ultrafast lasers. We're gonna measure freeform optics with high accuracy with the machines of DEMCON, and we're gonna have something super cool. The best one, we say the best for the last. We're gonna actually have a programmable beam tuning of a fiber laser to go from single mode to ring mode beams. Quite fascinating. Let's get started. I can't wait. It is 4 o'clock in the Netherlands. Today, talking to all the world. The first company is one of my passions. Many people told me that quantum was something for the future. Quantum is here. Quantum products are being reached in the market. Miraex is one of the key companies who have been epic on bringing quantum knowledge to photonic sensing, to fiber sensing, and even bringing it to harsh environments. Kicking off the show today from Miraex, we had the co-CEO Nicolas Abelé to talk about MOMS photonic sensing solutions for harsh environments. Nicolas, thank you very much for being with us all the way from Switzerland. The floor and the attention of everyone goes to you. Nicolas, the sentence of Epic 2021 is, you are muted. You need to unmute yourself. For the next meeting, I'm going to have a sign that says you are muted.
All
Nicolas,
right.
the floor is yours.
Thank you very much. So it's my pleasure today to really present to Miraex a new product at Miraex, which is a photonic sensing solution. It's what we develop for predictive maintenance, anomaly detection, and real-time asset monitoring in harsh environment. I mean, just before getting into a bit of detail, who we are. I mean, we are located in Lausanne, beautiful Switzerland. We are a spin-off from the EPFL. Our background is quantum physics, quantum optics, but also machine learning and data analytics. And we are developing full stack, I mean, hardware and software, photonics and quantum products. The core technology is really coming from a semiconductor-based background. It's a mix between semiconductor, a mix between optics, and a mix between machine learning to do 3 products, a photonic sensing solution, quantum sensor, and quantum transducer. And today we are basically launching the photonic sensing solution. For 3 applications, I mean, the main focus of photonic sensing solution is industrial solution. Industrial application, we talk about energy, oil and gas, you talk about aerospace, you talk about agri-tech, every position where you have a harsh environment effectively. When you say harsh environment, it's not necessarily linked to high temperature. It can be magnetic field, could be high voltage, like in railway, could be high shock, high pressure, waterproof, explosive environment. And this is where typical solution does not work because they are based on electronic. And this is where we come with our photonic solution, because we use photons. We don't use electricity, not electricity at any point in a measurement spectrum. Means that we can measure vibration, we can measure pressure, acoustic, temperature, electric field with this new product, the photonic sensing solution. We have basically 5 features, 5 characteristics that we can extract from the device, from the environment where we measure. But we providing a full stack means we provide to the customer, and that's really the key thing of this product, is that within harsh environment we provide actionable data to the customer, so process data. So customer doesn't have anymore to take analog output of the sensor and try to dig internally with software and hardware, etc. We provide directly the data that he needs to perform predictive maintenance, to perform anomaly detection in this harsh environment. And because we are extremely small, our sensor is millimeter range, we can be at the heart of the device, meaning we can have the best data from there. Less noise, the best data. And we are co-designing with effectively the machine learning to extract, to remove noise, to remove parasitic, and extract the best actionable data from this environment. So that's really, this is a snapshot on the product radar. Today, we are ready for piloting. So this is really a plug and play solution. You plug it to a computer, you get the data analysis. You see the tiny sensor here, it's 2 millimeter apart, so that can fit in any places, even in the heart of the nuclear plant. That's working because we are insensitive to radiation. From the data standpoint, because customers are interested by data, and this is part of the key product asset, is that we provide this actionable data, this clean data to the customer for this anomaly detection and real-time predictive maintenance. The machine learning part is key there because we are running a specific know-how there to do supervised and unsupervised machine learning to automatically extract the anomaly. We don't need to code anything. The software is providing the output directly. For the benefit of the customer, which is predictive analytics, I mean, we reduce operating costs, we reduce the loss of failure, reduce inspection time, and increase throughput. That's all the benefits we provide. Where in oil and gas is attacks environment, explosive environment, you need to have photonic sensor because we cannot create sparkle because we don't have electricity. It's as basic as this. And this environment is where a critical asset costs a lot of money and can make a really strong downtime there, where we provide a turnkey solution, very plug-and-play solution to get directly actionable data or closed-loop control. Cryogenic, you can be in cryogenic because we're coming from the quantum. The quantum world is cryogenic world. Obviously, this is where technology is from. So cryogenic is our typical environment, as much as really high temperature. A nuclear plant, you mentioned nuclear plant, this is also a harsh environment where critical asset has to be monitored real time. And they also need a turnkey solution. And we are insensitive to radiation, we are insensitive to high voltage, we are insensitive to electromagnetic perturbation. That's the beauty of photonics. So thank you. You can contact me if you want to have more details. We are ready to run pilots in many different industries, from aerospace to nuclear to agri-tech, everything where every location where you have harsh environment.
Thank you very much, Nicolas. I already said in many meetings that Miraex is one of the ones to watch. And the idea of revolutionizing the world of photonic sensing by actually adding vibrometry and actually adding the new parameters that standard FVG sensing cannot measure gives you a huge advantage. I'm pretty sure that many of the people who are watching this meeting are super interested on seeing if we can apply this to their particular need. Nicolas, this is an EPIC meeting, so don't be surprised with the EPIC question. What can you do for the other 670 members of EPIC, and what can they do for you?
And I mean, we are, 600 people from EPIC, we use optoelectronics. So we use light source, we use detector. I mean, we need to have the best devices here because that is part of the full solution to be the more and more sensitive, because sensitivity is key. I mean, if you think about predictive maintenance, the more sensitive you are, the better you can predict the future. So you need to start from there. So from the supplier standpoint, that is key, but also from the customer standpoint, we can optimize your equipment. Right now, we are in application where you have plasma. You know, plasma is a big electromagnetic perturbated environment. Today, there's no sensor that goes inside. So we can optimize equipment. We are there to optimize manufacturing line. We are there to solve big problems. So yeah, if you have such problem in harsh environment, I mean, we're here.
Today, you come to this meeting with a full developed product solution. And you are targeting some markets that require actually very high volume. How does the supply chain look like? Are you ready to go into these high volumes? And what kind of companies could maybe help you along the way?
Yeah, so right now it's a very good question because we obviously we're a roadmap. Right now, this product is not, I mean, size-wise, you see it is not ready for high volume. It's ready for niche market, like 1,000, 10,000 parts market, where it's, you know, high value added. At the same time, we are developing a photonic integrated circuit. That's really our roadmap with the same benefit of the sensor. Sensor is already small enough. No, that's okay. Edge controller will become tomorrow a photonic integrated circuit controller together with an ASIC. And so that's peak. We're gonna design it ourselves, but we need to have the support and the manufacturing capability of the EPIC team, EPIC members, to be able to design it. We're kicking off now. We just had a support, like a very massive support from the Swiss Confederation to start this photonic integrated circuit design.
Furthermore, Nicolas, you talked to us about the oil and gas as being one of the harsh environments. It is no surprise here, the oil and gas market is not living the best year of the history. However, when it comes to fiber sensing technologies, at the EPIC meetings, we actually scouted 3 big markets that are going to be huge in the coming years. The first one was the monitoring of the engines, of the car, of the electric car. On the second one was endoscopy and actually having fiber sensors for the medical market. And on the third one, railways. Are you in contact with the right companies? Of course, you should come more of the EPIC meetings so we bring those users, but are you in contact with those companies? And did you find some low-hanging fruits beyond oil and gas?
Yeah, so I mean, our really 3 focus is oil and gas, is agri-tech, with explosive environment, is railway, is aerospace. I mean, it's 4 focus. And railway is key because railway is high voltage and high electromagnetic perturbation, where they need, and today railway is behind in terms of predictive maintenance, clearly. Because it's a complex infrastructure, so you need to have standalone devices that can run on the train, provide real-time full network. I think they need to stop doing planned maintenance and just pinpoint like a measurement in one specific location, but they need to put this on the train because the train is the thing that goes all around. That's the thing that gives you full network, real-time information on the catenary, high voltage, on the wheels and on the rail, which is high electromagnetic perturbation.
One final point. Space. The space technologies in Europe have been flourishing. We are working very closely with the European Space Agency. They are very interested in new approaches, especially for the fiber sensing. We had a meeting a couple of weeks ago when we had the roadmap. How is the position, taking into account that you're targeting harsh environments? Vibrometry is one of your added values. What is the position for space and what kind of companies maybe can help you there?
So, I mean, space, we basically have these two products. Photonic sensing can work for space really already from the test bench, like in wind tunnel or in a high temperature test of a booster, etc., where they basically burn sensor, and they need to have sensor that can sustain a really high temperature, high pressure. But also the second product we are developing, which is not, I mean, it's ready for POC work, which is a quantum sensor, and that works for radar, you know, and for SATCOM. One of the big limitations in SATCOM right now is the bandwidth. I mean, data bandwidth is limited. I mean, between other things, by the just after the antenna, you get the amplifier, and this is the electronics noisy amplifier. If you replace this by the quantum sensor, then you can increase bandwidth. And that's for SATCOM, but also obviously true for I mean, radar on Earth. And so that's really our focus on for the quantum sensor is for radar application and SATCOM.
On the 26th of February, we have an EPIC quantum technology meeting on sensors for the defense sector. I want you there, Abelé. Thank you very much for starting the meeting the way it should start. And let's continue with the program. Thank you very much. We go now to one of the companies that I have in my heart. We go now to Belgium and we talk about distribution, design and IP protection of photonic integrated circuits building blocks. And for this, we go to IPKISS 3.4, the product of Luceda Photonics. Martin Fiers have been very interactive with many EPIC members, helping them with the process of getting getting an idea to a silicon photonic chips. Martin, thank you very much for being with us today. The floor and the attention of everyone goes to Ghent, goes to Belgium, goes to you.
Hello, thank you. Can you hear me?
Loud and clear.
Okay, perfect. Thank you very much for inviting us.
We can go to, yes.
Yeah, you can see it. Okay. Thank you everyone for listening, and thank you for having us here. I'm Martin. I'm one of the co-founders of Luceda Photonics, and I will talk about our new product releases for Luceda. A quick word on our company. We were founded in 2014 with our headquarters in Belgium. And our vision is to help photonic IC designers enjoy the same first-time right experience as electronic IC designers. And the way we want to go towards that is by using our software called IPKISS. IPKISS is our photonics design platform, so I'll shortly explain what IPKISS is about. It's a design platform centered around Python. As you mentioned before, we all love Python in our company, and we think it's a very efficient way of representing photonic integrated circuits. And so we start from a single component definition, and from that we can do different types of activities. For example, doing layouts with parametric components, generating 3D virtual representations, which you can then send to a simulator such as our own built-in Comfort or to a third-party tool. And we have our own circuit simulation engine called Café. And with Café, we can actually run circuit simulations, but at the same time verify the integrity of your circuit, because there is a tight link between circuit and layouts. We have a vast offer of PDKs from around the world, but we also offer services where we build your PDK, or we support you in building your own PDKs or libraries. We also have a module called the ADWG Designer, which is obviously for building arrayed waveguide gratings. It's easy to build layouts and to run simulations, and because of Python, there's the flexibility to easily try out various configurations. This tool allows you to go from high-level specifications, say center bandwidth, free spectral range, all the way through synthesis to design, to layout, to simulation, and then a final DRC clean tape-outable device. There's also links with other companies in the PDA, EDA ecosystem. So we have IPKISS EDA, with which we link to LEdit from Siemens EDA. So that everything that you've built in IPKISS in Python, you can then bring into a graphical user interface, such as LEdit, and then you can drag and drop the components and do optical and electrical routing. There are simulation links, so from within IPKISS, you can then generate these 3D representations and send them to, for example, a CST Studio Suite or ANSYS Numerical FDTD, and we also collaborate with VPI for the system level design. So what's new? In Q3, we launched Luceda Academy, and this is our new online learning platform, and it allows you to get acquainted with IPKISS very quickly. So we have a lot of tutorials, and we're gradually, or like on a rapid pace, adding new content to it, also application-specific examples. So that is launched. And then at the end of last year, we launched IPKISS 3.4. And then soon in Q1 of this year, we will launch an updated version of our ADWG Designer. This presentation is about IPKISS 3.4. So what have we done with IPKISS 3.4? It's really our next step in towards helping companies to build up their IP. So if imagine in a PIC design, when you do PIC design as a company, you typically have this kind of hierarchical representation where you have a foundry at the center, then you build your own libraries, and then you have your designs on top. And with IPKISS 3.4, we've made it even easier to then take those libraries and bring them within an EDA tool, such as Siemens, and we've greatly improved this link. But equally, you can then take those libraries and then start to do layout in IPKISS. And as your design becomes bigger and bigger, you might have more and more libraries, but because everything starts from Python representation, you can take the advantage of modern version control tools, such as Git, to really become flexible, scalable, and really scale up your IP creation flow. So this is actually represented in a video, which I will show next, which is our IPKISS 3.4 release video. And after that, I'm ready for questions.
This is the story of Dennis and Eva, two integrated photonics designers working in the same team. The results of a previous tape-out just came in, and they were asked by their manager to improve the measured design. Will they be able to submit a redesign in time? Of course. Their design flow is based on the IPKISS Photonics Design Platform by Luceda Photonics. Thanks to the single central component definition, Dennis and Eva can reuse the design done by their colleagues with minimal effort. With version control, Dennis and Eva keep improving on existing designs, even when created by others, by working on separate branches and merging different changes in one final design. They can create their own library of components, smoothly building on top of an existing PDK. Using Python, IPKISS parametric cells make it easy to design, document and automate the photonics design flow across all design stages. Dennis and Eva can immediately visualize the outcome of their ideas in layout and simulation. Route your components with a simple click in IPKISS EDA. Activate your IP inside LEdit and LEdit Photonics by Siemens. Write your design story now with IPKISS. Join Dennis and Eva on academy.lucedaphotonics.com.
Fantastic, Martin, and fantastic, Dennis and Eva as well, of course. Martin, one thing, this is an EPIC meeting, and in EPIC we have foundries, we have designers, we have IP companies, we have system integrators. What can you do for them? What can they do for you?
What they can do for us, we very much love working closely together with our customers, and so whenever everything we do, we try to learn from our customers, and that's really something we take really as one of the values of our company, is that we're human-centric. So we want to be close to those people, and we learn from them all the time. So whether it's just a simple support question or it's more about the longer term, what they want to do, we really want to learn from you. So that is how they can help. Especially also from the foundry side, there's a lot of challenging work today in terms of standardization and building models. I think this is one of the main challenges today in order to get the photonics design to the next level. And so we really try to collaborate closely with foundries in that respect.
Martin, this is a breakthrough, because one of the challenges that the interactive photonics community keeps having is the IP management. Making sure that people can actually collaborate without revealing their secret for the next interferometric sensor for detection of FVG variations. So, Martin, this is what you are aiming to try to help people to work together while keeping their own secrets, correct?
Well, let's say that in the beginning, we're more focusing on the creation of IP. Let's say protection is in a later stage. I think at the moment, one of the big bottlenecks is to scale up your team. And we've taken the approach of Python as a programming language and reusing all of the techniques around it from software development to make efficient design flows. And that's our starting point, to try to scale up. And there's actually a lot of successful software companies managing their IP that way. And so we think we can translate that concept back into photonics design. And so that's step one.
I'm going to acknowledge now all the support I'm getting from all the Python fans in YouTube. So hello, everyone. Everybody's commenting. But beyond that, Martin, for me, one of the breakthroughs on Luceda was the cooperation with other companies. This is what makes you great. Today, you actually explain how to go from the Python programming interface to the very well-known and used LEdit. Is there any next steps or making easier, not easier because I love Python, but any way of having the most visually oriented companies to interact with Luceda?
Yes, yeah, we're definitely having plans there. Nothing too much I can reveal right now, but we are definitely working on more graphical ways of representing your photonics circuits. And again, Python there is very well suited. It's very popular in data science, where visualizations are very important. So we can actually take benefit of those techniques and incorporate them in our software. That is one way, but indeed at the same time, because of that flexibility which is offered, and also thanks to standards such as open access, this allows us to indeed interface with other software vendors. And a lot of other software vendors are also embracing Python, so this is an easy way that we can exchange information with each other.
As a user of IPKISS in my past years, all I have to say is that for me, that was the best solution to reuse previous designs. It was always very easy to have a design and find exactly the position to actually take it, parameterize it, and multiply it for different positions with different parametric parts. With this new breakthrough that we have here, this is going to be pushed to the limit, right?
Correct. Yes, we want to actually extend on that. We want to make it more and more easy to bring your knowledge and the simulations and all the projects that you have to reuse them in different tools, but also but starting from the IPKISS design flow. So you start with describing your photonic circuits within Python with all the views around it. It can be layout views, simulation views, model views. You can describe them all from IPKISS, and then from there you extract multiple representations in different tools, or you build your own designs. So we wanted to keep it flexible as it is today, and at the same time strengthen that vision by going more to graphical representations. So that's definitely something to look forward in the near future.
Martin, for the peak designer teams, that we have in Malaga, hello, in Lille, in Krakow, in Warsaw, these people who are really, how do they get to try this software?
Well, as I mentioned in Q3 last year, we launched Luceda Academy. So that is really our go-to platform now. And actually, it's online, so you can already have a look and see at the different application examples. There's an application example, for example, for building cascaded Mach-Zehnders. But soon with the ADBG designer, we will also put some examples on how to build arrayed waveguide gratings. So that's really where you can get started. That would be the starting point.
Do you know when you make a huge difference in this field, Martin? You are so approachable. As a designer, every time I got stuck, I could just pick up the phone and say, Peter, I need help. And it was really easy to get that access. Never lose that. And for all the peak designers in the world, get in touch with Martin and love Python. You need to love Python. Thank you very much, Martin. And let's continue with this amazing program. Oh my God, so far a fantastic meeting, having so much fun. Why don't we go now to cross the Atlantic? Why not? I love crossing the Atlantic. We cross the Atlantic and we talk to Teraxion. And the reason we talk to Teraxion is because they have something super cool to announce. They're actually going to use Acousto-optics to transform, to vary, to alter ultrafast lasers. And for this, we have René Dionne, product line manager from Teraxion. René, thank you very much for being with us today. The floor and the attention of everyone around the world goes to you. I have you muted, which is good because the sentence of EPIC 2020. Yes, let's unmute yourself. The screen is clear. You can leave it, and now we unmute. Yes, we need to. René, you are muted. Tobias,
okay.
Yes, very good.
I'm okay now.
We hear you, we see you. The floor is yours.
Yes, thank you, everyone. Thank you, Jose. So I'm René Dionne, product line manager for ultrafast components at Teraxion. I'm presenting today our brand new Acousto-optic modulator for industrial and medical ultrafast lasers. Manufacturing state-of-the-art FBGs since year 2000, Teraxion has developed other strength over the years in advanced optical component packaging, silicon photonics, laser, phase locking, and RF photonics, to name but a few. We are ensuring that every new product meets the industry requirements. Teraxion addresses now three main markets. Laser component and optical sensing were developed by leveraging our telecommunication product expertise. We then developed new innovative components for laser manufacturer, which now accounts for more than 50% of our revenues. And the first ultrafast laser component was manufactured already 15 years ago. Back in November, we introduced an extended tunable pulse stretcher with EPIC. At that time, I told you that Teraxion was expanding its ultra-short pulse component product line. Well, today, Teraxion is bringing all of its ultrafast laser knowledge into an acousto-optic modulator for pulse picking applications. I like to use these building blocks. They represent Teraxion overview of a CPA ultrafast laser. Teraxion offers dispersion compensators for the mode lock oscillator, fixed and tunable pulse stretcher, and as for 2021, a 10 nanosecond acousto-optic modulator for pulse picking. It allows user to vary the amount of pulse per second that go through the amplifiers. In a CPA laser or regular MOPA laser, a lower repetition rate directly increases the amount of energy per pulse to meet the requirement of diverse applications in material processing or even some imaging applications. Fiber-coupled pulse picker can be prone to reliability issues, mainly because they require fast rise time while sustaining large amounts of RF power and optical peak power. Resolving these issues was the focus of our development. We added beam expander to our design and developed a strong bonding of the acoustic transducer. By using low outgassing components, we also avoid long-term degradation of the optics. Our 10 nanosecond AOM enable the efficient, clean, and reliable pulse picking of mode lock laser up to 50 megahertz. To ensure the highest performance out of your AOM, a high-performance RF driver is also highly recommended. You know, Teraxion has been designing RF communication component and controlling phase array antenna over 15 years now. Our RF driver offers the industry best-in-class RF stability. In ultrafast lasers, this ensures high pulse-to-pulse stability for demanding applications. Industrial and medical applications all require stable processes, fewer downtime, process adaptability while remaining cost-effective. Laser must then ensure constant performance, be able to deliver pulse on demand, and last for years without interruptions. This is why we promise that our AOM will deliver high pulse-to-pulse stability, flexible pulse picking at any duty cycle, and long-term performance in all conditions. The AOM is another step in our journey to remain a key component manufacturer for ultrafast laser designers. More than an FBG company, Teraxion is increasing its presence by bringing new technology to the market. I invite you to contact me or our sales department to select the appropriate component for the specific laser and market that you're targeting. Building an ultrafast laser is a challenging task that becomes much easier when doing it with the right partners. Thank you, everyone.
Thank you very much, René. And I can't agree more. I'm a huge fan of many ultrafast laser companies. I would like to say hello to my Fluence friends in Poland. It is very clear that you have something amazing in your hands. It is very clear that you are targeting the ultrafast laser community, but I'm going to ask you anyway because this is epic. The epic question goes to Canada. What can you do for them? What can they do for you?
Yes, of course, Teraxion, we're in the ultrafast industry since many years, but we also cover a few other markets. And we like to work close with our customers. So if you have any specific need, our goal is to simplify lasers. Ultrafast lasers are very complex and they must achieve a very high performance level. So if you have any idea of a combination of functions or a combination of technologies that could help to improve the laser performance or reduce the overall cost, then we're ready to look at your ideas, and we welcome partnership at Teraxion.
René, one of the huge breakthroughs of this AOM is the pulse peaking with very high, very high, I'm gonna say it, very high damage threshold, sorry, the live thing, very high damage threshold. You are talking to 1 kilowatt of damage threshold. Is there any particular application that you believe is the one driving this particular segment?
Actually, it's for laser designers are looking for more flexibility in the laser design architectures. You have the choice of using your pulse picker right after the oscillator or after the pulse stretcher. Of course, after the pulse stretcher, you have a much lower peak power involved, but before pulse stretchers, the peak power is much higher. So it gives you more flexibility into the design of the laser.
René, since the COVID-19 started, and I said COVID-19 again, I promise I wouldn't mention it. Since it started, we have organized at least 10 meetings talking to ultrafast lasers to end users. And there was one requirement that always came to the table, which is long-term stability. They just want to switch it on and make sure it works with lower maintenance. I know for many years that Teraxion always puts that as one of their key unique selling points. How do you test that? And what can perhaps you can provide to these end users who are doubting about the long-term stability of ultrafast lasers?
Yeah, you know, at Teraxion, we have a long historic of manufacturing components for telecom. So we have a strong knowledge into damp heat testing, the Telcordia qualification for telecom. And in lasers, either ultrafast lasers or high power lasers, there is no standard in the industry. But when you have a strong background in component testing, I think that helps quite a lot.
Thank you very much, René. We have a question for you, actually room for cooperation. Tobias Muller is the CTO of IPKISS. Tobias, thank you very much for being with us today. What's on your mind?
Yeah, thanks a lot, Jose. Yeah, I was looking at the presentation, looking at your modules, seeing that you have pigtailed modules over there, and you mentioned that you have 10K units, which you produce per year. And so I was wondering, in terms of manufacturing of these units, is that done already with some certain automation? It's always like the question, does automation only make sense for larger volumes, or how do you gradually step into automation also to improve quality, long-term stability? That's also an issue where it can help. And yeah, that's maybe my main point of interest. If maybe we can be a partner for you in helping you manufacturing these systems or scaling up production.
All right. Yeah. So at Teraxion, of course, this AOM is a new product for us. So we do not manufacture this product already in large volume. But of course, when the volume are reaching thousands or tens of thousands of units per year, automation is required for alignment procedures or for manufacturing. So and automation, alignment, vision is all required into volume application. So yeah, would be interested to look
Sounds
at.
great.
Oh my God, there is so great room for cooperation here. And Tobias, great job what you're doing with IPKISS and really amazing on the active alignment and assembly of photonic integrated circuits and any optoelectronic device all the way to laser diodes. Great job. One of the ones to watch, IPKISS. But let me continue with this meeting and let me continue to one thing that always amazes me, which is the huge development that we're going to have in Europe on freeform optics. And you can make freeform optics, but can you actually measure them and measure them fast and accurate? And for that, we have a great company in EPIC, one of our system integrators and machine makers, DEMCON. And DEMCON is here to tell us about their breakthrough on ultra-fast measurement of aspherical and freeforms. Jing, thank you very much for being with us. Thank you for being at DEMCON. And tell us how we can help you making DEMCON even greater than already is. The floor and the attention of everyone goes to the Netherlands. Goedemiddag. And the sentence of EPIC 2020, everybody knows it, you are muted. Jing, you are muted. We need to unmute you. Yes. And then go presentation mode. And let's hear about measuring freeform optics.
You can hear me now?
Yes, the floor is yours.
Good. My name is Jing. I'm actually from DUI, which is part of DEMCON. First of all, thank you very much for giving us the opportunity to present our company and our products. DUI is actually established in 2017, so it's a rather young company, but we build our products based on the proven nanomorphos technology from TNO. For the people who do not know what TNO is actually a Dutch applied scientific research institute in the Netherlands. And our mission is to provide the best form metrology products for aspherical and freeform optics. As mentioned, we're part of the DEMCON group. I guess most of you already know DEMCON, but just in case, DEMCON is a design and engineering company established in 1992, and it has more than 700 employees. Since I only have a few minutes and I have to introduce DUI, I would like to share the story of DUI with you. 17 years ago, a few master and PhD students, including actually our current CTO, Rens Hanselman, they went on an epic journey to build a dream form metrology machine for the optics manufacturing industry, since no one can make what they cannot measure. So what this dream machine needs to do is it has to be universal. It means it has to measure many different kinds of shapes, from flat to freeform, sphere, asphere. It has to be large, meaning it has to cover optics. Back then, it has to cover optics up to 500 millimeter in diameter. It has to be accurate, like an interferometer, and it has to be fast, meaning the optics measured in within 10 minutes, few minutes, and it's a long contact, so it can avoid potential damage caused by scratches or potential contamination. So the journey went on for a few years. What has happened? Have they managed to build a dream machine? This is what they built. It's called nanomorphos, and it actually works like a giant CD player. But it is a dream machine. Depends who you ask. Technically, it does meet all the 5 aspects which they intended for. And over the years, it gets more and more famous. So TNO actually has quite a lot of suitors for this machine, but there was no match. So why there was no match? Because TNO wasn't in the position to offer a product because it's a prototype and it's not really serviceable. It's not very user-friendly. And most importantly, it is not very commercially appealing. However, the suitors keep on coming. So what has happened? Our CEO led a team with our CTO, actually at the peak of the time, 75 engineers from DEMCON. They went on another epic journey, trying to transform nanomorphos into NMF. As you can see, they did a very good job by simplifying nanomorphos to NMF, chopped up a few letters. But of course, there are a lot more to it. As you can see, the machine is a lot smaller. It is much more serviceable, and is also scalable, meaning that we can actually manage to build different size of the machines within a short time. However, the most important thing, it is now commercially attractive. Nevertheless, it also looks a lot better than the previous prototype. So now let's have a sneak preview of our products.
DUI has developed the NMF 600S, a freeform optics measurement machine based on the famous nanomorphos technology of TNO. This machine is capable of nanometer accuracy, non-contact measurement of optics up to 600 millimeters, ranging from flat to aspherical to freeform, from convex to concave, from circular to non-circular apertures, all without setup changes. Our proprietary optical probe combines 5 millimeter range with 7 degrees acceptance angle. This enables high point density mid-spatial characterization in minutes, even on wild freeforms and on polished or ground surfaces. Slope-independent, traceable nanometer accuracy is ensured with a patented closed-loop metrology system with a silicon carbide reference frame and a stabilized helium-neon laser with wavelength compensation. Other features include an easy product mounting and alignment interface, intuitive workflow-based software, powerful fitting and analysis algorithms, and data export for iterative machining. The NMF 600S, interferometer accuracy with coordinate measuring machine versatility.
All right, so this is a dream machine. So let's go back to the 5 aspects which the journey started for. Universal. This page includes all the different type of optics which we have measured on our machine last year. So from small to large, and from ground to also coated surface, from on-axis to off-axis. It's all kinds of optics, flat, A-sphere, including also cylinders, ellipsoid. So this box is checked. And it's a non-contact, as you can see also in this video. It has a dual-stage servo probe based on the confocal principle. The optics is loaded on a spindle table, so the spindle table it rotates at 1 revolution a second. This enables the measurement done in minutes. And of course, the most important thing is performance, the accuracy. As you can see, since we do not have a standard freeform optics, we can measure a standard flat at different angles. So this is the results showing a flat piece measured at different angles from 0 to 7 degrees. The RMS value is varied between 4 nanometers. So it is very accurate, even for wired freeform optics. And what else can it do? It can also measure, if you measure at a very high point spacing, means you zoom in, you can actually see the manufacturing defects. It's a very unique feature. So what do we have in our product family? So far, we have released the 600, meaning up to 600 millimeter in diameter, as well as the 350. However, on demand, because the platform is scalable, on demand, we can also build 800 and up to 1000 millimeter in size. So thank you again for giving me the time to introduce to you the DUI NMF 600S and 350S. Are you interested? You can contact us or visit us in Delft, of course, after the corona. Thank you very much for your time.
Thank you very much, Jing, and thank you very much for this, because I'm really connecting all the companies in the world on freeform optics. And as soon as we can travel again, we're going to have a fantastic meeting in Rochester, New York, with all the different technologies that we can do. And I want you there, Jing. But Jing, you just talked to us about an amazing piece of equipment, and I have 670 companies here who want to work with you. What can you do for each other?
Yeah, so first of all, actually, the main purpose I'm here is because when we introduced our products, we are just hit the COVID. So all the trade shows, exhibitions were canceled. Of course, I'm hoping that if you know certain companies, especially, as I mentioned, right, one cannot make what they cannot measure. So if you know optics manufacturing companies who actually need such a tool, please ask them or get in touch with me. And as you also see, because we are making a machine using interferometer, using optics probe, I'm sure there are also companies within this consortium who can also offer products to us. So let's chat what we can do for each other.
For me, one of the clear things of this machine is the versatility. The versatility is huge, right. And we are talking about a huge revolution that we have now on wafer level micro optics using freeform. So my question is, what is the smallest dimension that you can measure?
Actually, we are looking in our roadmap, we're looking into a different type of probe. So the smallest we would like to measure is mobile phone lens, because it's also a large market. And currently, of course, there are existing solutions, but those solutions also has limitations. So the smallest we would like to measure is a mobile phone lens. The micro lens you're mentioning, I think, is something different.
I would like to acknowledge all the different developments that we have in Europe right now, from aspherical, from SUS micro-optics, from more photonics, from nil technologies. You need to get in touch with DEMCON, with DUI, but I'm going to call you DEMCON because I love the machines of DEMCON and the reliability that DEMCON has given to this idea of the nanometers of TNO. Jing, thank you so much. Let's go to the last presentation of today. It moves so fast, the time, right? We go to Optoprim. And the reason that we go to Optoprim is because we had a chat with them and they told us about the new product they're actually doing for the programmable fiber laser beam shaping. And you're going to be amazed about the ring mode beams they actually managed to develop. To present that, we have Christian Schröter from Optoprim. nLIGHT programmable fiber lasers are here for you. Thank you, Christian, for being with us today. Thank you for being our final speaker of this fantastic news show. The floor and the attention of everyone goes to the lasers of nLIGHT, goes to Optoprim. The floor is yours.
Thank you very much. Yeah, thanks for having us. Thanks for giving the chance to talk to you. So let's start the presentation. So yeah, we talk about the nLIGHT AFX, first programmable single mode fiber laser with ring mode beams option. My name is Christian. I'm from Optoprim, and I'm happy to guide you through this little introduction today. So let's start. Some facts about Optoprim. Optoprim is a distributor for photonics and laser components here in Europe, and we are in the industrial area, scientific area, active. We are founded in 1994, have around about 65 employees right now, different locations with Paris, Munich, Monza, and Rome. And for sure, a strong focus of us is the industrial laser applications, material processing, and we're offering all the services around it. So a quick look into our applications lab, quick introduction to what we can do. Basically, we have different machine setups. We have different laser sources. So from CO2, fiber lasers, diode, ultra short, UV. So we really try to address applications with the right technical tool in terms of laser. And yeah, we have all the assist gas and everything what is needed, plus the analysis equipment to run tests for our customers in our lab. Then in terms of service, for sure, industrial customers really require best support. So we offering installation support, training, application support at customer side in our lab, have the field serviceability, spare parts, and consulting. This is all our, let's say, core offerings to our industrial customers within Optoprim. As we are a distributor, we have worked with many, many companies over the world. So from Asia to US, within Europe, and nLIGHT is one of our key partners. And they are manufacturer of high power fiber lasers and also high power semiconductor lasers. They are located in US. And as you can see on the bottom right, they really start their production from semiconductor lasers, their own optical fibers, and then into the fiber laser. And yeah, so let's start with the AFX, what kind of fiber laser this is. So every application is different. Single mode lasers are often very required. So compare a single mode laser maybe with a very fine point paintbrush. Other applications are more like you need a multi-mode laser. So it's kind of a thicker paintbrush. And at the end, nLIGHT has developed last year a laser AFX, which really offers both, or basically the full palette of spot sizes and the different beam profiles on top. And that makes it very interesting. And on the next page, you can see a small animation how it works. So that's the rack mount laser. That's the fiber end and the collimator. And on the fly at full power, you really can see how the laser power is differently distributed and forms into different beam profiles. And that really drives different applications to another stage, basically, and gives a lot of flexibility to our customers. Some specifications to that laser, to the AFX laser. So we have 7 switchable beam modes. We have a core diameter of 50 micron and then 45 micron in the outer diameter ring. And all between we can switch on the fly different beam qualities. It's also suitable to scanners. And as this is the first single mode fiber laser, which is switchable with different ring modes, we also are finalist for the Prism Award as a nice side fact maybe. And on the right, you can really see the 7 different beam modes, true single mode, different power variations within these indexes, and then the full or almost full ring on the right side. And yeah, the ring mode offers really nice properties on different applications. And that's what we are going to look into it right now. So now one example for welding. So welding is very important in different applications, e-mobility, in medical, in different industries. And at some point you need the sharp knife. So you want to have the very deep penetration keyhole welding. So you're going to use the smallest spot within the laser, so only the core. Then you have everything in between. And on the other hand, there are also customers which want to have conduction welding modes. So then you're going to use the ring. And depending on the application, you can switch on the fly during the application, or from part to part, you change your basically setup without changing any in the optical part. Then another very interesting field, and where we have already a couple or quite good of experience, is in the additive manufacturing. So here you have lattice features. There you're going to use again the fine brush. Then you have kind of mixed geometries. There you're going to use the intermediate settings. And if you really want to have high productive and really fast processes, you're going to use the ring mode and do the bulky parts. And for that, we have a small video, or we're looking into some more properties of the AM application. So especially the melt pool velocity is quite important for additive manufacturing. And there it is, like with the ring. So with the index 6, you have 25% only of the original velocity. So that means more stable process than before, compared to a Gaussian beam or even a defocused Gaussian beam. And here with this video, you really can see how different it is. On the top, there's the ring, not that bright, less better, and also this kind of vacuum effect, which is very interesting compared to the Gaussian beam on the bottom, more spatters, more bright. This is a nice high resolution film about an AM process, and belongs to, credit to Michael Rasch. And on the other hand, for sure, productivity is the other very important topic. And there we have compared the standard ring mode or standard fiber laser to a defocused fiber laser and our ring mode laser. And we have really achieved quite high factors of being faster, 3 to 6, depending on material and spot diameter. And also here we have a nice proof of concept as well from Fraunhofer ILT, our friends from Aachen. And here you can see the reference parameter of ILT, the max scan speed, and the max productivity. So we have really kind of doubled the speed, or even like tripled the weld volume, because of this very good shape within the weld or in the powder bed. And we are very interested to move forward with this kind of interesting technology in the AM, in the welding, but also in cutting. And it's an early stage. We see a lot of promising results, and looking forward to cooperate with the different institutions, like you can see here, but as well, we are working for sure with our integrators, which are very known here in Europe. So thank you for your attention. Danke, merci, grazie from Optoprim. And if you have any questions, please let me know.
Danke, merci, grazie, gracias, Christian, for a great presentation. And I'm amazed by very fast switching of the blades. That was out of this world. There are 670 companies here who want to work with you. What can you do for each other?
So what we can offer them is like, we really are, as you see, we are distributed in different fields. We can offer sales platforms. We can offer sales channels. We are a very motivated team in the different areas, have a lot of application knowledge for the individual industries. And that is one thing. And for sure, as we have core technologies, very innovative products, we are always happy to start developing maybe new processes with integrators and start something new, like with the ring mode in the powder bed from additive manufacturing.
We have a question in the room, René from Teraxion. What's on your mind?
Yes. Hello, Christian.
Hi.
I had a question regarding the competition. So we've seen over years a few other products that bringing this mode switching technology to the market. So I was wondering what is your differentiator? Maybe the speed of switching or the different modes.
Yeah, exactly. So one thing is really the speed of switching from one mode to the other. So this is really done in a couple of milliseconds. So below 30 milliseconds from low to lowest index to highest index. We also can do it at full power, which is also very interesting. So it doesn't matter. We have also the high power platform up to 15 kilowatt with the same features. It's all in fiber. That means this is very, very robust compared to any free space optics where you do the manipulation. And we have also different fiber designs. So 2-core, 3-core. So there are many differentiators. And we see a lot of flexibility as we can really switch the full power from the core to the rings as well. In the single mode, it's a little bit different, but especially for the high power, you can imagine 15 kilowatt in a 100 micron core, and then 15 kilowatt in a ring. It's phenomenal to see the switching in 30 milliseconds.
It is quite fascinating. What you're saying is that you can go from one beam shape to another one while keeping the average power constant?
Correct, that's correct.
And do it in milliseconds.
Yes, that's right. And that's very important. So especially in the additive, you can really, if you have fine features, maybe more bulky features, not within, let's say, layers, really switching on the fly. That's the core advantage what nLIGHT's AFX and also CFX technology provides. That's right.
What is the maximum power? You mentioned at some point 550 watts. What is the maximum power? Also, you can mention fluence. I would love that too.
So for the AFX I introduced to you today is 1 kilowatt for the moment, so single mode to ring mode. But there's also the CFX platform, which is basically the same technology, but up to 15 kilowatt. So that is really...
My fingers are crossed for the Prism Award ceremony. I'm betting on you here. I'm betting on you. This is a very good one, Christian. Thank you very much. To close the meeting, Martin Fiers from Luceda Photonics has a question to Jing from DEMCON. Martin.
Jing? Yes. I had a small question. Just so I was thinking, imagine that I want to do some low volume testing. I have made something, I would like to measure it, but I don't have the financial capabilities of buying the tool. I can imagine that there can be multiple smaller companies that would like to do this kind of thing. How would you deal with that?
Right. So it kind of depends how much you want to measure. We definitely could arrange a measurement service for you. And as well, because we, as well as small companies, we know how that works. So we can also arrange some sort of a lease contract if that's interesting to you.
Okay. No, thank you.
Yeah.
And thank you very much for another great meeting. It is 5 o'clock and today I really loved it. We have 5 breakthroughs. We have companies in EPIK who provide fantastic technology and also a fantastic place to work for their employees, because you cannot be a successful company without providing a great place to work for your employees. For these great success stories of EPIK, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com. jose.pozo@epic-asoc.com, and I will make the introductions because I love doing that. It's been great, from lasers to integrated photonics, from 3D printing all the way to fiber sensing. What an amazing hour. On behalf of an EPIK meeting, of an EPIK team with medical experts, integrated photonic experts, laser experts, quantum experts, innovation managers, marketing and events manager, a CFO, a CEO, everyone dedicating their lives to the photonics industry. Please keep in touch with us because we love our jobs and we also love to keep you advised of all the different markets of photonics. Have a look. This is the agenda for the upcoming online technology meetings, and tomorrow we are dealing with mid-infrared from 3 to 12 micrometers wavelengths. Camerons, QCLs, it's going to be fascinating. Until then, take care of each other, wash your hands, wear a mask and stay safe. I can't wait to keep traveling again. Take care. Bye-bye.
Thank you.
Thank you.
Bye, Jose.
Bye.